Good day, my peers all over the world. Again, Salima. Thank you for watching my YouTube channel. Today, we are dealing with the subject mathematics, and in our mathematics today, we'll be talking about set theory. Set, set theory. So, under set theory, there are some terminologies we really need to trash before talking about the main thing they want to talk about there is the Venn diagram. But let me just explain the terminologies here. Once you get the terminologies, that's all. One, we have universal set. Two, we have intersection. Three, we have union. Four, we have null sets or empty sets. Five, we have disjoint. Just follow me. It's very simple. Very simple. So when you say universal set, from the word universal, universal means everything. It has everything. Just like water is universal. When you say air is universal, meaning water can be found everywhere, air can be found everywhere. That's the meaning of universal. So when you're now saying set, set is talking about collection of elements. This set theory, collection of elements. Those elements could be numbers, could be alphabets. You know, I've told us mathematics, we play around figures and alphabets. So here we'll be playing around figures. What they are just doing here is to be speaking word problems. Once you can just unravel the word problems, you can see that set theory is very simple. So like here now, you say universal set. Universal sets. That one is represented with this U with long tail or like this. Then you have intersection that was represented with N. The union that was represented with U. Why non-set? You can use theta to represent non-set, or you do this without anything inside. Without anything inside. I think that is clear enough. So if you are not talking about universal set now, I'll use some examples to explain this so that it can be very clear. I can say, for instance, you have a set of numbers. Let's say set, this means universal set. So I use this or I use this to represent universal set. So I'm now giving us an example now. Let's say a universal set contains numbers from 1 to 30. Contains number from 1 to 30. Maybe I'll say that P contains multiples of 4, and Q contains, let's say, perfect numbers, and let's say R contains X less, or let's say X, okay, X greater than um greater than 3, X less than, from, let me put it this way so it can be easy, is 0 less than X, and the X, oh, let me just give this one so that I can enjoy it first. X, do it starting from the 0, I can also say X less than 3 and less than 10. S is less than 3, less than 10. I want to explain something here. And if you have been following up with my mathematics, okay, sorry, I explained this one in chemistry, you would have understood what I'm trying to do here. But let me just explain it in brief before, okay, by the time I get to this place, I'll explain it. So the question would just say, find 1 P intersection Q. 2 P intersection R. 3. They can say P intersection Q intersection R. 4. They can say P P union R. Then 5. Like I say P intersection R, P intersection Q intersection R. So now we want to solve these questions. This is the question they've given us. They only give all this information. They are not expecting you to use your knowledge in mathematics to be able to demystify all this, to be able to break all this one down. So for us to break all this one down, like I told us, I said universal set contains all the elements. This P, Q, R are regarded as subsets. 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 So sub means that they are contained, they are under the universal set. It means that the multiples of 4 will be found in this our discussion, because the universal set in this our problems you want to solve is between 1 and what and 30. So any other information that will be supplied will be done with as regards to the what to the universal set. Here they said P is a multiple of 4. Then when I say what are the multiples of 4? When they say multiples, it means that 4 will be the what? The common difference. I will teach us that one when we get to arithmetic progression. 4 will be the common difference. For instance, if I say 4, if the common difference is 4, it means that the next number will be what? 8. The next number will be what? 12. The next number will be what? 16. The next number will be what? 20. The next number will be what? 24. The next number will be what? 28. The next number will be what? 32. Is 32 no more than this? So 32 is not part of our universal set. So you are going to stop at what? 28, because whatever you may want to get for P must be contained in the universal set, because this is a subset. So now I've gotten all the elements in what subset P. Now let me now go to Q. Q is what? Perfect numbers. If I say perfect numbers, a perfect number is a number that has exact square roots. If you have not watched my video on salt, please go and watch it. So when you say perfect numbers, it has exact square roots. So what are the numbers that has exact square roots between 1 and 30? You now come. The first number is 1. What is square root of 1? 1. The next one, you look at it. After 1, you have 4. What is the square root of 4? 2. So 4 is a perfect numbers, or perfect number rather, perfect square. The next one, after 4, you have 9. Square root of 9 is what? 3. And how do you know this? It's very simple. Just go to the smallest number. The smallest number is 1. 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. Is 36 not more than this? It's more than 6. So 36 is not part of this subset Q. So we have gotten the contents of subset P. We have gotten the contents of subset Q. Now next is R. Then I say R is less than, X is less than 3 and less than 9, as less than 10. If you want to interpret this, listen. You can see, if I say X is less than 3, it's different from me saying X is less than or equal to 3. If I say X is less than or equal to 3, it means that the first value of X is going to be what? 3. That's the meaning of this information. But if I say X less than 3, it means that the first value of X is going to be what? 2. Because equal to is not there. I believe that is clear. So let me repeat it again. If I say X is less than or equal to 3, When you see this equal to, it means that the first value of x is going to be what? 3. Because of this equal to that is there. But if I remove this equal to, the way we have it there, x is less than 3. It means that the first value of x is 2, not 3, because equal to is not there. So if I now bring that principle to this place now, it means that this one would now be interpreted as x less than 3, that is 2. We have 3, 4, 5, 6, 7, 8. Now look at it. It says less than 10, but not equal to 10. Not equal to 10. The way I should have written this, sorry, is this. So for clarity, I'm very, very sorry. It should be 3 less than x and x less than 10. So if I say 3 less than x, from what I've explained now, look at it. 3 less than x. It means that the first value of x is going to be what? 4. 4. Because if I say 3 less than or equal to x, is different from 3 less than x. If I say 3 less than or equal to x, it means that the first value of x is going to be what? 3. But in this expression, 3 less than x, it means that the first value of x is going to be what? 4. 3 less than x. So if I want to interpret this now, I will now have 3. The next one will be what? 4, 5, 6, 7, 8, and 9. Because I said x is less than 10, but not equal to 10. In some questions, if I want to really confuse you, I can just put it the way you have it now. I will just say 3 less than x. I will now put less than or equal to 10. This expression is different from this. If I want to write out the content of this, I will include 10 if equal to is there. But here there is no equal to. It means that 10 is not part of the content. I believe that is very, very clear. So if you are not getting it, watch the video over and over, then you get it right. So we have interpreted the subsets. We have gotten the content of each of the subsets. We know what subset P is now. We know what subset Q is now. We know what subset R is now. The next thing now is to find P intersection Q. When they say intersect means meet at a point. Meaning what I have, you also have. That is what they call intersection in set theory. Meaning what you can find in me, I can also find in you. That is what intersection. If you now look at this one now, in this question now, intersection, what can you, they said find P intersection Q. What can you find in P and you can equally find in Q? You now go to P, then what are the elements in P? We have 4, 8, blah, blah, to 28. Then what are the elements in Q? We have 1, 4, 9 to 25. Then what can you find in this one and you can equally find in this? You now start from the first number. From here, what's the first number? 4. Here, what's the first number? 1. Can you find 1 here? No. Can you find 4 here? Yes. So the number that you can find, you circle it. 4. Any other number again? 8. No. 12. No. 16. Yes, you can find 16. This is 16. Any other number again? 20. No. 24. No. 20. So there are two numbers, 4 and 16. So it means that P intersection Q, sorry, I have to rub up a part of this place. P intersection Q is now equal to what? 4 and 16. Because those are the two things you can find in these two. They have 4 and 16 to be the only thing common to them. That we'll call intersection. What is common to the two? What I can find in P, I can also find in Q. That is what? The intersection. So the next one is P intersection R. P intersection R. What can I find in P? And I also find in R. That is P intersection R. So you now go to P again. So this is P. Then you now go to your R. This is P. And this is R. What do you have in P? And you can also find in R. Now you can find 4. Yes, anything again? 8. So 4 and 8. 4 and 8 is what? P intersection R. The next question, P intersection Q intersection R. Meaning what I can find in P, I can also find in Q, I can also find in R. You now go to this one. This is P. This is P. P, we have 4. Can we find 4 here? Yes. Can we find 4 here? Yes. So P intersection Q intersection R is equal to, the first one you can find is 4. Go to the next number, 8. Can I find 8 here? Yes. 8 here? No. So go to the next number, 12. Do you have 12? No. 16? Yes. Can I find 16 here? Can you find 16 here? Yes. What about here? No. 20. Do you have 8 here? No. No. 24? No. No. 28? No. No. So P intersection Q intersection R is what? 4. The next question, P union R. I want to explain union now. No, I've explained intersection, I've explained universal set. Union now. When they say union, union means carry all the subsets in what you are asked, lump it with the next one you are asked. You know, here they ask us what? P union R. It means that you should pour the elements together. What do you have as elements in P? We have 4, 8, 12, blah, 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 blah. What do you have in R? We have 3, 4, 5, 6, like this. You pull the two together, but don't repeat number. Don't repeat number, I repeat. Don't repeat number. By the time you pour the content of P to R, you know, you now find 3 to be the first number. P union R will now be equal to what? By the time you add, this is R, you have added it to this. The first number you're going to see is 3. That's the least number. Followed by what? You know, this one has 4. This one has 4. You have to go to pick just only one 4. 4. What else again? You can see 5. Can you see 6? Yes. 7, 8, 9. So there is no 10. The next number you're going to see is what? 12. The next number is what? 16. The next number, 20. The next number, 24. Next number, 28. I think that is very clear. Union just means add their subsets together. Then write it out one by one. But don't repeat elements. Just write it. This is what they call elements. All these contents. Don't repeat the elements. If an element occurs more than once, just write it once. Don't write maybe 4, 4. Like what you have here. You know you have occurrence of 4 more than once. You have occurrence of 8 more than once. We only picked one. So that is how to do union. So non-set. So if I say non-set now, non-set means, for instance now, maybe I check A, P, and I checked Q, and there is nothing common to the two of them. Then I will now say that, since there is nothing common in P and Q, is a what? A non-set. I think that is very, very clear and straightforward. That is part A of our set theory. Our next class is going to be on Venn diagram. How they use Venn diagram to explain all these terminologies that I wrote out. Universal sets, union, intersection, null sets. So please don't miss my next class. If you have not subscribed, please do so. And for those who have subscribed, I pray for you that the good Lord will continue to support you. Thank you very much. I remain Sir Lumaj. Bye for now.